Hello boys of class 8. Welcome you to the online class of mathematics. I am Abhijit sir. Today we'll start revise chapter 8, that is quadrilateral, and I will solve a CQ about quadrilateral related theorem. So let's start today's session. First of all, let's see the CQ. PQRS is a parallelogram whose diagonals are intersecting at M. Now look at the questions. Number A, difference between square and rhombus. Number B, prove that diagonals of PQRS are bisect each other. Number C, prove that if opposite sides are equal and parallel of PQRS, then it is a parallelogram. So the condition is given that if the opposite sides are equal and parallel, then any quadrilateral can be parallelogram. So let us start the solution from A. There is difference between square and rhombus. Number one difference that is diagonals of square are equal while diagonal of rhombus are not equal. Second difference, angle included between two sides of square is right angle, but angle included between two sides of rhombus is not right angle. Third difference, if you want you can give up to 2, but if you give 3 there is no problem. So third number is rhombus diagonals bisect each other at right angle, but squares diagonals not bisect at right angle. They bisect, but the angle between two diagonals is not right angle of a square. So that is the difference between square and rhombus. Now let us move to the second question answer. That is, we have to prove that diagonals of parallelogram bisect each other. Here is the general enunciation. Diagonals of PQRS are bisect each other. For that we need to draw this figure. Here PQRS is the parallelogram and the diagonals PR and QS intersecting at M. So here is the particular enunciation. PQRS be a parallelogram whose diagonals PR and QS intersect each other at M. It is required to prove that PM equals to RM and QM equals to SM. So for proof we don't need any construction here. We can direct start from proof. So proof. But the definition of parallelogram, we know that opposite sides are parallel and equal. So PQ and SR, these are two opposite sides and they should equal and parallel. Since they are parallel and PR is their transversal, so the angle QPR equals to alternate angle PRS. Similarly, QR parallel PS and QR parallel PS and QS is their transversal, so we can write PQS alternate angle QSR. Now in triangle MPQ and triangle MRS, if you go, angle MPQ equals to angle MRS and angle MQP equals to angle MSR. So when two angles of a triangle are equal to another two angles of another triangle, then obviously third angle should be equal, and here angle PMQ and angle SM are equal because they are already vertically opposite angle. So if three angles, and here PQ equals to RS because opposite sides of a rectangle, so when two angle and sides are equal, then you can say they are they're congruent. So if they're congruent, then their opposite sides and similar sides should be same. So MB equals to MR and MQ equals to MS, which was required in the proof. So that's the complete proof of B. Now let's start proof of C. The general enunciation is, if the opposite sides are parallel and equal, then we have to prove that PQRS is a parallelogram. That means here we have to take PQRS as a quadrilateral. Here is the figure. Particular enunciation, let PQRS is a quadrilateral where PQ and equals to RS, PS equal to QR. That means opposite sides are equal and they are parallel also. PQ parallel SR and PS parallel QR. It is required to prove that PQRS is a parallelogram. For this proof, we need to join PR. So that is the construction. Now, since PQ equals to SR and parallel SR and PR is the transversal, so we can write angle QPR equals to alternate angle PRS. Q SPR equals to PRQ. Since QR and PS are parallel and PR they are transversal, so angle SPR equals to angle QRP. Again, in triangle PQR and in triangle PSR, PQ equal to SR as their opposite sides of quadrilateral and they are equal. PS equal to QR, same, opposite sides of quadrilateral, and PR is the common sides. So three sides of a triangle equivalent to three sides of another triangle. So you can say these two triangles are congruent. So when these two triangles are congruent, their similar angles should be also same. So we can write PSR equals to angle PQR. Now similarly we can prove that angle QPR equals to angle PRS. Now if we write angle QPS, it can be split into angle like QPR and SPR and their summation is QPS. So QPR is already equals to PRS and SPR is already equals to PRQ. So we can write instead of QPR and SPR, it's PRS plus PRQ, that equal sum of angle QRS. So we can write QPS is equals to QRS, which is the opposite sides of rectangle or quadrilateral PQRS. So already we seen that two opposite angles are equal. Here another two opposite angles are equal in PQRS quadrilateral. So with the definition of parallelogram, we can say when opposite sides are equal and parallel and opposite angles are equal, then it is a parallelogram. So PQRS is a parallelogram. So that completes the proof of C. Hope you have realized. If you have any problem, then you can ask any question in the comment section. We will do another CQ from next chapter in the next class. So stay fine. So bye for today.